Hello and welcome to lesson number 2 here at Reignite Hope. Again, I'm Steve, the director of Reignite Hope, and we're going to cover some more important welding information, learn some new things here today. Hope you got your notebook with you. Please, if you don't, pause this, go grab your notebook. And we're going to be on pages 22 and 29 here to begin with. And we're going to talk about the 5 different types of joints. This is very common stuff that you will hear all day long as a welder. So you need to know what this is all about. So if you turn to page 22 in your notebook, you're going to see the 5 different joint types there. I've got a couple pieces of aluminum here with me that I'm going to demonstrate this with. But basically, when we're welding 2 pieces of metal together, we can orient them in 5 different ways in order to achieve whatever it is we're trying to do. One thing we can do is we can form what's called a butt joint. And that's where we just simply butt 2 metal together like that, and we would weld the joint that is created by that. That is called a butt joint. Just like this, 2 pieces butted together. Another joint type is what we would call a lap joint, where we just take the 2 pieces of metal and we simply overlap them with one another. And now we've got a seam here we could weld, and we've also got one on the back side that we could weld. This is called the lap joint. Then a third type of way we could orient these 2 pieces of metal together would be to form what we call a T-joint. Kind of looks like a T if I put it in that position. A T-joint here. And that would allow us to weld the 2 pieces together there on that side, or weld the 2 pieces together on that side. Our T-joint, a very common joint that you'll be welding wherever it is you might go and work. Another type of joint we might have is to form a corner out of our 2 pieces of metal. So we place them like this, and now we've got a corner, and we could weld the inside of this corner, or we could weld the outside of the corner. But either way, that is called our corner joint. And then lastly, we've got something called an edge joint. We take our 2 pieces of metal, put them together like that, and weld the edge right here. It could be this edge, this edge, this edge, or this edge, but that is our edge joint. So those are the 5 common joint types that you just need to have in your head and be familiar with those. By the time we get through the course, you'll know these like the back of your hand. So take a look at those pictures. They're also pictured on page 29 in your notebook, but I think 22 might be a little bit better picture. 22 and 29 for the 5 joint types. Okay, next we want to cover the 4 joint positions, so different than types. So types were the 5 different ways that we can put metal together, like here with the butt joint or the T-joint and so forth. Now though, we could take any one of those 5 types of joints and position them in any one of 4 positions. So let's take my butt joint here, for example, where I butted the 2 pieces of metal together. I could weld those in this position here, which we would call a flat position. It's just like it's laying flat on a workbench, and we would go ahead and weld the 2 pieces of metal together. We could have them turned this way though, and now this is what we call the horizontal position, and we'd weld it from left to right or from right to left horizontally. We could also take our butt joint and now put it in the vertical position, and now we're going to weld it uphill or downhill, but now we're welding it in the vertical position. And then lastly, we could put it overhead like this and weld the 2 pieces this way. That would be the overhead position. So again, we've got a flat position, we've got a horizontal position, we've got a vertical position, and we've got our overhead position, the 4 joint positions. Now, there's a little bit of terminology that goes along with these. Each one of our positions actually has a number associated with it. And you'll find those on your notebook as well. I think on page 18 it'll have that. But the flat position is always a number 1. Our horizontal position is always designated with a 2. Then our vertical position is always designated 3. And then lastly, our overhead is a 4. So now we've got a number associated with each one of the 4 positions. And then we have 2 types of welds that we could do with that. So, for example, if we've got our butt joint again here, and we're butting 2 pieces of metal together, that's actually forming a groove in between the 2 pieces that we would weld. That'd be called a groove weld, and we would abbreviate that with a G. So if I were welding that in the flat position here, and this is a groove weld, we would call that a 1G. If I were welding it in this position, the horizontal, now we're going to call that a 2G, and then of course vertical would be our 3G, and overhead would be our 4G. So if somebody's certified, let's say for example, to weld 3G, and many of you will get that certification, 3G, that means you're certified to weld a groove in the vertical position. A groove in the vertical position. The only other type of weld that we're going to add into this is sometimes we'll often call our fillet weld, F-I-L-L-E-T. Think of it as like filling in a corner. And so on our T-joint here, we would be filling in this corner, and we call that a fillet weld, which gets abbreviated now with an F instead of a G. So if I were welding, go back to maybe our lap weld, for example. I'm taking my 2 pieces of metal, overlapping them here. I've kind of got a corner here I'm filling in. It's not a groove anymore. There's no gap between the 2 pieces that I'm filling in. It's a corner here that I'm filling in. So if I were to weld it in this position, the flat position, filling that in there, that's going to be my 1F. If I were to do it this way, horizontally, now that's my 2F. If I were to weld it vertically, that's going to be my 3F, and then my 4F would be this, welding in, filling in that corner overhead. So a fillet weld would apply on a lap joint like this. Our T-joint is also fillet welds. Again, we're filling in a corner. Our corner joint is also a fillet weld, filling in the corner there. So all of those would get that F designation, and then the number would be whichever position this gets placed in. 1F, 2F, 3F, or 4F, and again, we could have 1G, 2G, 3G, and 4G. A lot of you are going to get certified this semester in 3F. You're going to end up welding a T-joint like this in the vertical position. So 3 is vertical, remember, and you're going to weld it vertical. It's a fillet weld. You're filling in the corner, so you're going to get a 3F certification from the American Welding Society. If we did it this way, you'd have the 3G, okay? 3F and 3G. Some of you are going to get both a 3G and a 3F. Now for the third item on your lesson there, we're going to talk about stick electrodes for a minute and the designations of that. So these are only used in the stick welding, and this is the electrode. This is what carries the electricity into the metal, causing it to melt. Remember, this is our flux coating here on the outside that when it burns, it creates that smoke protecting our arc from the air. These come in different sizes and different designations, and the 2 types of stick electrodes that we're using here at Reignite Hope, and the 2 most popular ones out in the world, that's why we picked them, because most companies are using these 2, are designated as a 70-18 electrode and a 60-10 electrode. This kind of grayish colored one I'm holding here is a 70-18 electrode, and this, I guess that's orange, is designated as a 60-10 electrode. And these numbers refer to some of the qualities or characteristics that the electrodes have, and so you'll pick different ones for different welding that you're doing. And I want to just talk a little bit about these numbers and what they mean. And again, you please memorize these numbers because you might get asked these on a job interview. They might say at the school that you got trained at, what were the electrodes that you used? And you want to say, not the gray one and the orange one, you want to say 70-18 or 60-10. So what do the numbers all mean? If you look in your book on page 24, we've got some designations there that'll help us out a little bit with this. But the 70 in this and the 60 in this refers to something called tensile strength. And that really tells us how strong of a weld bead this is going to lay down. So a 70 series electrode will lay down a bead with a tensile strength of 70,000 pounds. In other words, it would take 70,000 pounds of force to pull that apart. That's a lot. So that's what the 70 means, whereas a 60 series electrode, like our 6010 here, would take 60,000 pounds of tensile strength to pull that apart. So it just tells you a little bit about the strength of the bead. So some jobs you're working on, they're going to be fine with the 6010. Others are going to need the 70-18. And so you'll just use whatever is required for the particular piece that you're welding. The 1 here is a real important number for us too. The 1 tells us what positions you can weld this electrode in. Now remember, we had 4 joint positions: flat, horizontal, vertical, and overhead. Not all stick electrodes will weld overhead. Not all of them will weld vertical. So you need to pay attention to that and know which ones will do which. If it's a 1 designation here in the number, that means it's an all-position electrode. You can use this in the flat position, welding this way, horizontal position, vertical position, overhead. They'll weld in all positions. If it had a 2 or a 3, you can use it in. So it's nice to have an all-position electrode, and that's important when you go to buy these, to make sure that you've got an electrode that's going to work with whatever position you're welding in. The last number there, we won't say much about that. That has to do with some of the chemistry going on here with the electrode and some of its characteristics. The main thing I want you to know today is, again, just to learn those 2 numbers. Know that basically the 60 and the 70 talk about the strength of the bead, and the 1, really important, tells you that you can use it in all positions. Okay, so now I want to talk a little bit about stick machines. Here again, I've got one of our electrodes. This is the 70-18 electrode. Here is the stinger or the electrode holder that we use for stick welding. It simply clamps in there. You can clamp your electrode in various positions. If I clamped it this way, I might want to be doing some overhead welding, right? Position number 4. I might put it at a little bit of an angle like that if that works out for me. Or down like this might work. Just depends on what angle you need to comfortably get in there and do the weld. And a stick machine setup is going to be pretty simple. You're just going to have really, the main thing you're going to be concerned about is your amperage setting. Now in some of our welding processes we adjust voltage. With MIG and flux core we're adjusting voltage. But with stick welding and TIG welding we're adjusting amperage, how much electricity is traveling through our circuit. So we're going to have an amperage setting on our machine, and you might set it at 100 amps, 120 amps, 90 amps, just depends on the thickness of the material. The thicker the material, the more amperage you want traveling through your electrode. If we get to where turning our electrode up, or machine up really high, a lot of amperage, we might go with a bigger diameter electrode to handle the heat. If we're lower amperage, we might go with a skinnier, thinner electrode, not needing as much heat. But amperage is what we're going to set at. Most of the time back here, you're probably going to be running somewhere between 90 and 110 amps on most of the machines. But just know that that's the main variable you're going to use to adjust for stick welding, is setting your amperage. Of course, the other things you're learning here already, keeping a really tight arc length. You don't want your stick very far away from the bead. You want it really close to it, a short arc length. You want to get your travel speed steady and right. Too fast is not good, too slow is not good. And you want to be steady. You don't want it wiggling around. You want to get your elbows into your ribs if you can, and really maybe even lean on the table and just be as steady as you can, moving the electrode across the joint there. Okay, lastly on our lesson today, I'm going to talk about something really important called polarity. Now, as welders, we don't need to know a lot about electricity. We just need to know a little bit about it, enough to set our machine right for the process that we're trying to use. So polarity comes in 3 different types, and we're going to talk about them and why you'd use one versus the other. Here again, I've got a stick electrode holder, or the stinger. And polarity just tells us which way our electricity is traveling in our path. We could set it up so that my stinger here, my holder, is positively charged, or we could set it up where it's negatively charged, or we could set it up where it's an alternating current and the electricity is going in both directions. So if we had it set up to where this is positively charged, electrons will actually be coming through the ground cable into your table, into the metal that you're welding, up the electrode, into the stinger, and back to the machine. That's because this is positive. Electrons are negatively charged. They're always looking for positive, and so they're going to go in this direction. Our electricity is going to be heading toward the stinger and back to the machine. And we call that direct current. Electrode positive. It's direct current because in direct current, electricity only travels in one direction. It's just one direction all the time, whichever way you've got it set up. It's either going to be traveling into the stinger or out of the stinger into the electrode. That's our direct current. And then our designation is whether it's positive or negative. The abbreviation for that would be DCEP, direct current electrode positive. If you're reading articles about welding, stick welding, they'll often use these terms, so we need to know those and understand what they mean. Now, we could change the machine and make this negatively charged. And now the electrons are traveling in the opposite direction. Now they're coming out of the machine, up into my stinger, down the electrode, down the stick electrode, into the metal I'm welding, into the table, into the ground cable, and back to the machine. Now the ground cable is negative, this is positive, or excuse me, this is negative, now the ground cable is positive, so the electrons again are looking for positive, so they're going to come out of here, down the electrode, looking for that ground cable that's positive now, and back into the machine. So this would then be electrode negative, and so we would abbreviate that as DCEN. So what does that mean and why? Well, if you look on page 23 in your notebook, you'll notice that some electrodes will only work with certain polarities. Another polarity we have is alternating current. That's the kind you have in your house, coming out of your wall. And it's called alternating because the current goes back and forth 60 times a second. It goes in this direction, then it goes in that direction. It's alternating its direction. And that's great for lights and things like that, but for welding, sometimes we use it, sometimes we don't. AC current, some machines will only produce AC current, so you need to make sure you've got a stick electrode that works with AC. If you look on that page in your notebook there on page 23, you'll see that our 6010 electrode, the orange one I had, it won't work on AC. So if you've got a machine that only produces AC current, you got to get a different electrode. The 6010 won't work. Our 7018 would work with it, but not the 6010. Also, different polarities have different penetration abilities. So sometimes we'll pick a polarity that's going to give us the penetration that we want. The deepest penetrating current is right here, DCEP. This is the deepest penetrating. Our DCEN, that's going to be the least penetrating, and our AC is going to be in the middle. So, if I'm welding something really thick, something really critical, that boy, that's really got to stay together, that weld can never come apart, I really want that electricity to penetrate deep and that bead to penetrate deep, I want DCEP with stick welding. That's going to give me the deepest penetration, and then I'll pick an electrode off that chart that will work with DCEP. Now maybe I'm welding something really thin though, and I'm afraid of burning through, and I don't want to penetrate too deep or I'll blow a hole in it. Then I might pick DCEN, that's the least penetrating polarity, and that might be the one I use. And then something in the middle might be AC. Most stick welding is going to be DCEP. Most of the time, I'd say probably 90% of the time, that's the polarity you're going to have, is direct current, electrode positive, and that works out really great for your both your electrodes that we're talking about, our 7018 and our 6010. They both love DCEP. Now, our polarity doesn't just apply to stick welding, it applies to all kinds of welding, the MIG welding, the flux core welding, all of that, TIG welders as well. So you TIG welders, for example, we're mostly going to deal with two types of polarity. We're going to deal with our DCEN, and we're going to deal with our alternating current, abbreviated AC. So if we're welding aluminum with TIG welding, we're always going to pick AC current. That's the current you want for aluminum. That current going back and forth, in the metal, out of the metal, in the metal, out of it, because when it comes back, it knocks that oxide layer off the top of the aluminum and causes a cleaning action to take place, which is really critical for aluminum welding. For steel welding, we're going to use DCEN. So then our TIG torch will be electrically negative charged, and that will be for, again, steel welding. For the MIG welders, most of the time we're going to go with DCEP. That's going to be the polarity that I would say 90% of the time you're going to use for MIG welding. Flux core could be either. So depending on which type of flux core we're doing, if we're doing flux core self-shielded, we're going to go with DCEN. DCEN. But if we're doing flux core dual shield, that's where we add a gas bottle member. We've got our flux inside of the wire, but now we're adding gas on top of it like the MIG welding. Now we're going to switch the polarity, and we're going to do DC electrode positive. So electrode negative, so our wire is negatively charged coming out of the torch. When we're doing self-shielded without the gas, positively charged wire. When we're doing dual shield, AC again for TIG welding, aluminum, electrode negative torch for TIG welding, steel. Now I guess you'd probably like to know what's going to be the quiz for lesson number 2. Now this week coming to Reignite Hope, remember you're going to have quiz number 1. We've already gone over that, and we'll review lesson 2, but then the following week you'll have quiz number 2. So here's the questions, the welding questions for quiz number 2. The purpose of flux is what? So remember that coating on the outside, sorry, I had to run and get that. On the outside of our electrode here, that burns and creates the smoky cloud around our electric arc and shields the arc from air. That's the purpose of the flux. Same thing for the flux inside the wire on flux core welding, shields the arc from the air. Then our second question for welding will be, what are the 3 types of polarity? So you're going to say direct current electrode positive, you're going to talk about direct current electrode negative, and alternating current. That's the three different polarities: DC positive, DC negative, AC. Direct current electrode positive, direct current electrode negative, alternating current. That's question number 2. AC, what's AC stand for? Real easy, that stands for alternating current. AC stands for alternating current, means that inside the wires of the electrical circuit, the AC current is making it go back and forth, alternating direction. What does DC stand for? Direct current. Direct current goes in one direction, either toward the electrode or away from the electrode, but in one direction, direct current. And then you've got 3 tape measure questions. So questions 5, 6, and 7 will be pointing to different spots on the tape measure and asking you to tell us what those are.